everybody. Today I am going to talk to you about laws of exponents. So laws of exponents are how we solve problems that involve exponents. There's certain steps and rules that we have to follow, and we are going to talk about a few of them today. So it's party time because I know exponents are super exciting. Spider-Man is super exciting. So let's get going. All right. So the first one is a product of a power. So product of a power means, product again means to multiply. So we're talking about when you are taking one term and multiplying it by another term, and one of those terms has a power, has an exponent. So for example, a to the n power times a to the n power. This means it would equal a to the m plus n. Because if you multiply powers that have the same base, so both of these have a base of a, you're going to add the exponents. So we just added m and n. So let's look, and I'm going to move my picture there because I just realized it's probably going to be the way. X to the third power times x to the fifth power. So again, the first thing I want to do is I want to look and see, do they have the same base? Which they do. They both have an x. So what I'm going to do, or what x to the third power means is x times x times x. And x to the fifth power is x times x times x times x. So if I were to multiply all of those x's together, I'm going to think about like how many x's do I have there that are being multiplied. So I count 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 x's. Now I can't put 8x because 8x means I would be adding the x's. We're multiplying it. So I need you to think of it like 4 times 4 is 4 squared because you're taking the number 4 and you're multiplying it 2 times. So it's the second power. Or 4 times 4 times 4 would be 4 to the third power because it's being multiplied 3 times. So this is going to be x to the 8th power because there's 8 x's. Now, I don't know about you, but I wouldn't want to have to do this every single time I'm multiplying. That's why we just use this rule of just add the exponents because 3 plus 5 is 8. So if we're multiplying, we keep the base the same, whatever it is, and we just simply add the exponents. They have to have the same base. I can't do this if I had a to the third power times x to the fifth power. I couldn't multiply them because they have different bases. So let's look at another one. So now we have x squared times 3 times x to the 9th power. Again, I broke this out. So x squared is saying x times x. 3 is just 3. And then x to the 9th power, there's a whole lot of x's there. So there's 9 x's. They're all being multiplied together. So I'm going to throw in those multiplication dots. So I need to simplify this. So it simplifies to 3 times x to the 11th power. So the 3, there's only a 3, so I can't multiply anything. All of these have a 1 in front of it. We know anytime you multiply 1 by a number, it's just that number. So it's just going to say 3. And then again, x and x, same base, so I can leave x there. And then I'm going to add the exponents. 2 plus 9 is 11. If I count all these x's, there's 11 x's there. So again, when you are multiplying a term that has an exponent, if the bases are the same, keep the base and then add the exponents. So this lady's looking, she's just as surprised. So all I have to do on product power is multiply the numbers and add exponents with the same base. Yes. So another rule is quotient of power. And if you remember back, quotient means when you divide. It's the answer to a division problem. So how do you divide when you have powers? So think about it. Division is the opposite of multiplication. So if we multiply, we add the exponents. When we divide, we subtract. We do the opposite of that. So here, I have a to the n power divided by a to the n power. We're just going to keep the a. The base, again, is the same. So we're going to keep it, and then we're just going to subtract the exponents. Now I'm in the way again. I'm moving up here. So to find a quotient of a power, you're going to subtract the bottom exponent from the top if the bases are the same. Again, the bases have to be the same. They have to be the same. These both have an a. They're the same. So I can just take the top number and I'm going to subtract the bottom number from it. So what that looks like is this. If I have x to the 10th power divided by x to the 6th power. So broken out, it looks like this. I have all of these x's and I have all of these x's on the bottom. I have 10 on top, 6 on the bottom. So what happens is if the same thing is on the top and on the bottom, they cancel each other out. So if I have that one on top, that cancels out. Another one on top, and cross one out on the bottom. It's like I'm making matches, right? So what happens is I keep doing that. Oh, I kind of got out of order there. And then eventually I've crossed out all 6 x's on the bottom, and I've canceled out 6 of the x's on top, and all that I'm left with is 4 of them, x to the 4th power. Again, that's a lot to do every single time. So if you just remember the rule to subtract 10 minus 6, you get the answer without having to draw all this craziness out. So you need to subtract. Let's look at another one. So this was a little bit more because there's a lot more going on here, but we're going to break it down, okay? So what I have here is like 3 separate division problems. I have 2 divided by 6, x to the 6th power divided by x to the 2nd power, and then y to the 8th power divided by y to the 5th power. So there's like 3 different problems there. So I'm going to start simplifying this. So 2 divided by 6, I'm just going to hold off for a minute. But x to the 6th power divided by x to the 2nd power, again, I'm going to keep the x, and I'm going to take 6 minus 2, and then y divided by 8 over y divided by y to the, I'm having a hard time here, y to the 8th power divided by y to the 5th power is simply, I made it go away. There it is. Y to the 8th power minus 5. So I can now simplify this. So 2 to the 6th power, or 2 divided by 6. I am recording this on a Friday, and it's been a long day and a long week. So 2 divided by 6 is 1/3. And then we have x raised to this power. So 6 minus 2 is 4, so it's going to be x to the 4th power. And 8 minus 5 is 3, so it's going to be y to the 3rd power. So when you see this, you're like, oh my God, there's so much going on there. Just break it into the separate division problems. So the numbers are one. These that have an x are another, and then the ones that had a y, those were another. So just break it into 3 separate problems, and you just solve it that way. So this dog is learning just as along with us here. So this is what you do. You divide the numbers, subtract the exponents, and that's what you do. And that's what we just did in that example. And then finally, for right now, is a power of a power. So this is when we are taking a term that is an exponent, and we're taking it and we're raising it to more of an exponent. So we're raising it to another power. When that happens, you are going to multiply the exponents. So still the same base, and we're going to multiply the exponents. That's what I just said. So we have x to the 3rd power, and we're going to raise that to the 5th power. I'm going to keep x. Or what that means is I'm taking x cubed times x cubed times x cubed times x cubed times x cubed. Again, I don't want to have to write all that out. So if I think about, well, how many of these do I have? How many 3's do I have? I have 3, 6, 9, 12, 15. Can I get 15 by just taking 3 times 5? Yes. So I'm just going to multiply the exponents, and it's x to the 15th power. Another example. What's going on over here? So we have a to the 4th power, and that's being raised to the 2nd power, times, there's no symbol there, but I know it means times a to the 3rd power raised to the 5th power. So I'm going to break this out. A to the 4th power, that's being multiplied twice because it's to the 2nd power. And then a to the 3rd power is being multiplied 5 times because it's to the 5th power. So here, I'm going to think back to the slide about what do I do when I'm multiplying and it has the same base. What do we do with the exponents? Well, we would add them together. So if I add 4, 4, 3, 3, 3, 3, and 3, I get 23. Or if I just took 8, so 4 times 2 is 8, 3 times 5 is 15, and then 15 and 8 make 23. So, now I'm covering my little Bitmoji up. So now go and make me proud, and you need to complete the practice on the 3 laws of exponents. So remember these 3 rules. 1, add the exponents when multiplying. 2, subtract the exponents when you are dividing. And 3, multiply the exponents when you are raising one to another power. So off you go to Schoology Assessment /Building Knowledge practice. It's unfortunate. It's called an assessment. Don't think of it as a test, but it's just a practice. Okay? If you have any questions, make sure you reach out and let me know.